What if I told you that right now, hurtling through the darkness of space, a rock larger than a skyscraper could be on a collision course with Earth?
This isn't science fiction or Hollywood fantasy, this is the reality that keeps NASA scientists up at night.
Today, we're diving deep into one of humanity's greatest existential threats, asteroid impacts. From the dinosaur-killing space rock that changed Earth forever to the cutting-edge technology we're developing to protect our planet. This is the story that could determine the fate of our species.
Before we dive into the potential devastation these cosmic bullets could cause, let's understand what we're dealing with.
Asteroids are ancient remnants from the formation of our solar system. Chunks of rock and metal that never became planets. While most orbit peacefully in the asteroid belt between Mars and Jupiter, some have broken free and wander dangerously close to Earth.
These near-Earth objects, or NEOs, are the focus of intense scientific scrutiny.
Every single day, our planet dances through a cosmic shooting gallery, and the stakes couldn't be higher. We've identified over 31,000 NEOs so far, but that's just scratching the surface of what's out there.
With each new telescope and detection system we deploy, we discover more potential threats lurking in the darkness of space. Let's turn back the clock 66 million years ago, to the most famous asteroid impact in Earth's history.
A massive rock, 6 miles wide, slammed into what is now the Yucatan Peninsula in Mexico at over 45,000 miles per hour.
The energy released was equivalent to 10 billion Hiroshima bombs detonating simultaneously. The impact created a crater 93 miles wide and sent billions of tons of debris into the atmosphere. This single event wiped out 75% of all species on Earth, including the dinosaurs. The skies darkened for years, temperatures plummeted, and the face of our planet was forever changed.
This wasn't just a disaster, it was an apocalypse that reshaped the entire course of evolution on Earth.
Fast forward to the present day, and we've had some uncomfortably close encounters. In 2002, an asteroid the size of a football field passed between Earth and the Moon, and we only spotted it after it had already gone by. In 2013, a smaller asteroid exploded over Chelyabinsk, Russia, releasing energy equivalent to 400,000 tons of TNT. The shockwave damaged thousands of buildings and injured over 1,500 people.
These events serve as stark reminders that space rocks don't need to be dinosaur killers to pose a serious threat.
Even relatively small asteroids can cause devastating local or regional damage, and we might have little to no warning before they strike.
How do we spot these cosmic threats before they become a problem?
NASA and other space agencies have developed an impressive network of ground-based and space-based telescopes dedicated to asteroid hunting. The Pan-STARRS telescopes in Hawaii scan the entire visible night sky every week. The Neowise Space Telescope orbits Earth, using infrared technology to spot even dark asteroids that reflect very little light.
These systems work together in a global early warning network, processing massive amounts of data to track known objects and discover new ones.
Every night, automated systems analyze thousands of images, looking for the telltale movement that distinguishes asteroids from distant stars.
Scientists use sophisticated tools to evaluate the threat level of discovered asteroids. The Torino scale, ranging from 0 to 10, helps communicate the risk to the public.
Think of it as a cosmic threat level system. A score of 0 means no risk, while 10 indicates certain collision with global consequences.
But determining an asteroid's threat level isn't simple.
We need to calculate its size, speed, composition, and trajectory with incredible precision.
Even tiny uncertainties in these measurements can mean the difference between a near miss and a direct hit. This is why continuous monitoring and refined calculations are crucial for planetary defense.
Understanding asteroids' physical properties is crucial for developing effective defense strategies.
These space rocks come in various sizes, shapes, and compositions.
Some are solid chunks of metal, while others are loose collections of rubble held together by gravity.
Some spin rapidly, while others tumble chaotically through space.
Their surfaces can be darker than coal or highly reflective. Each of these characteristics affects how we might detect them and, more importantly, how we might deflect them if they're headed our way. Scientists study these properties using radar, spectroscopy, and direct observation from space missions. What happens when an asteroid hits Earth depends on various factors. Size matters enormously. Objects smaller than 25 meters usually burn up in our atmosphere, creating spectacular fireballs but causing no damage. Larger asteroids can survive atmospheric entry and create local devastation. The truly large ones, like the Dinosaur killer, cause global catastrophes. The initial impact creates a massive crater, sending debris high into the atmosphere. This debris can circle the globe, blocking sunlight and triggering what scientists call an impact winter. The larger the asteroid, the longer and more severe this winter would be. When an asteroid enters Earth's atmosphere, it creates a massive shockwave and generates intense heat. Even before impact, this can cause widespread damage.
The Tunguska event in 1908 demonstrates this perfectly. A small asteroid or comet exploded in the atmosphere over Siberia, flattening 80 million trees over 830 square miles.
The pressure wave circled the globe twice.
If this had happened over a major city, the devastation would have been catastrophic.
Understanding these atmospheric effects is crucial for developing early warning systems and evacuation plans for different impact scenarios. Perhaps the most dangerous scenario isn't a land impact at all, but an ocean impact.
If a large asteroid strikes one of Earth's oceans, it could generate mega tsunamis hundreds of feet high.
These waves would travel at jet aircraft speeds, potentially devastating coastal cities thousands of miles from the impact site. The water vapor and salt ejected into the atmosphere would affect global weather patterns. Scientists use complex computer models to simulate these scenarios, helping emergency planners prepare for the worst while hoping for the best.
Now for the good news: humanity isn't defenseless against cosmic impacts. NASA's DART mission in 2022 marked a historic milestone. The first time we deliberately changed an asteroid's orbit by crashing a spacecraft into the asteroid Dimorphos. We proved that we can alter the course of these celestial bodies. This kinetic impact method is just one of several proposed deflection strategies. The key is early detection. The more time we have to act, the gentler the nudge we need to give an incoming asteroid to make it miss Earth. Beyond kinetic impact, scientists are developing other methods to protect Earth. The gravity tractor concept uses a spacecraft's gravitational pull to slowly alter an asteroid's trajectory. Another proposal involves using focused sunlight to heat part of the asteroid's surface, creating a jet of vaporized material that would act like a tiny rocket engine.
Some researchers even suggest painting asteroids white to change how they absorb solar radiation, gradually altering their orbits through a phenomenon called the Yarkovsky effect. Each method has its advantages and challenges, and the best approach depends on the specific threat we're facing.
Planetary defense isn't just a scientific challenge, it's a global political challenge. No single country has all the resources and expertise needed to protect Earth from asteroid impacts. The International Asteroid Warning Network coordinates observations and calculations worldwide. The United Nations has established protocols for sharing data and making decisions about potential threats.
This level of international cooperation is unprecedented in human history, showing how space threats can unite humanity toward a common goal.
What happens if we detect an incoming asteroid too late to deflect it?
Every major space agency and disaster response organization has plans for this scenario.
These plans include everything from evacuation procedures to managing the aftermath of an impact.
FEMA and NASA regularly conduct joint exercises simulating asteroid emergencies. These exercises have revealed both strengths and weaknesses in our preparedness.
They've shown that clear communication and coordination between agencies are just as important as technical capabilities.
The threat of asteroid impacts affects more than just public safety. It has significant economic implications. Insurance companies are beginning to consider cosmic impacts in their risk assessments. The global economy could be severely disrupted by even a relatively small impact, especially if it hits a major population center or crucial infrastructure. On the flip side, investing in planetary defense creates jobs, drives technological innovation, and could lead to valuable spin-off technologies. Some economists argue that asteroid defense should be viewed as a form of global insurance policy.
Looking ahead, several promising technologies could revolutionize planetary defense. Advanced propulsion systems could reach threatening asteroids faster. New telescopes will spot smaller objects farther away, giving us more warning time. Artificial intelligence is improving our ability to process astronomical data and predict asteroid trajectories.
Some scientists propose establishing a network of space-based interceptors, ready to launch at a moment's notice if a threat is detected.
While these technologies seem like science fiction, many are already in development. Not all aspects of asteroids are threatening, they also represent incredible opportunities.
Many asteroids contain valuable metals like platinum, gold, and rare earth elements. Water ice found on asteroids could support space exploration by providing drinking water and rocket fuel. Companies and space agencies are developing technologies to mine these cosmic resources. Understanding asteroids for planetary defense goes hand in hand with learning how to utilize them for humanity's benefit. This dual-purpose research could help fund more comprehensive detection and deflection capabilities. Despite the potential severity of the asteroid threat, public awareness remains relatively low. Most people associate asteroid impacts with Hollywood movies rather than real scientific concerns. Education and outreach efforts are crucial for maintaining public support for planetary defense programs. Scientists and communicators work to strike a balance between raising awareness and avoiding unnecessary panic. Social media and citizen science projects are helping to bridge the gap between scientific research and public understanding. The psychological effects of discovering a potentially hazardous asteroid shouldn't be underestimated. How would society react to news of an incoming impact? Historical examples of public responses to disaster warnings provide some insights. Clear, honest communication from trusted authorities is essential. Mental health professionals are working with emergency planners to develop strategies for managing public anxiety and preventing panic. The goal is to promote constructive action rather than paralysis or chaos. As asteroid defense capabilities grow, new legal questions arise. Who has the authority to launch a deflection mission? What if a deflection attempt causes unintended consequences? Who's liable if an asteroid is deflected from one country but hits another? International space law is evolving to address these issues. The Outer Space Treaty and other agreements provide some guidance, but many legal experts argue that we need more specific frameworks for planetary defense activities. The asteroid threat represents both humanity's greatest challenge and an opportunity for unprecedented collaboration. Every day we advance our understanding and capabilities, but there's still much work to be done. Support for research, development of new technologies, and international cooperation is crucial. The question isn't if a dangerous asteroid will head toward Earth, but when. Through continued vigilance and preparation, we can ensure that humanity is ready to face this cosmic challenge. Our survival as a species may depend on the decisions and investments we make today. If you found this deep dive into asteroid impacts fascinating, hit that subscribe button and notification bell to stay informed about the latest developments in planetary defense. Share your thoughts in the comments below. What defense strategy do you think shows the most promise? How would you react if we discovered an asteroid headed toward Earth? Join the conversation and be part of this crucial discussion about humanity's future.